Hello, welcome back. Let's round up the firefighting design. Let's make a quick recap. The fire hose reel and the fire extinguishers we placed uh, first aid firefighting systems. They are expected to curtail to prevent the spread of fire until the fire brigade come to site to fight the fire professionally, and that is why the pumps are designed to work for minimum of 2 hours. By then it is expected that the fire brigades have arrived to do the needful. um, we are using our discharge pipe of 50 millimeter in diameter, and that is why we chose to use a suction pipe of 75 millimeter diameter to make it bigger than the discharge pipe, in order to prevent cavitation and subsequent impeller damage, pump impeller damage. When the suction line is less than the discharge line, there will be cavitation, and that is detrimental to the pump impeller and seals. So the least you can do is to make the suction line to be equal to the discharge line. Even as at that, I don't advise you to do that. I always prefer the suction line to be a bit bigger. For this suction line, you can make it 75 or 63 millimeter diameter. We are choosing the discharge pipe of 50 millimeter diameter. Why? Because our building is not up to 15 meters in height. According to some publications, example, Design and Practical Handbook on Plumbing, authored by C.R. Mohan and Vivek Anand, buildings that are less than 15 meters height can use a firefighting discharge pipe of 50 millimeter diameter. If the building is more than 15 meters, it is advisable you use a higher diameter. So that is that for our recap. Now I want to introduce a jockey pump to this setup. What is a jockey pump? A jockey pump is a minor pump. What it does is it boosts this wet pipe, this discharge pipe, at all times. Over time there will be minor leakages, there will be evaporation when the weather is temperate, so there will be pressure drop. There will be the water in this pipe will tend to reduce. So the work of the booster pump or the jockey pump is to activate automatically once it detects that pressure drop, and boost this pipe to make sure that the pipe is always charged with water. It is not expected to fight fire. In the event of fire, the pressure drop will be much. Why? Because the fire hose rail is being utilized at that point in time. So the jockey pump does not have the capacity to reimburse this pipe. So that is why we have the main pumps. Now in the event of fire, these main pumps take charge and the jockey pump stays idle. The main pump, one will take over, which is the electric pump. But when there is power outage, when there is no electricity, then the diesel pump will take charge, and the electric pump and the jockey pump will remain idle. So that is the idea behind the jockey pump. So let's bring in something to represent our jockey pump. Alright, I believe this will do. So our jockey pump is now being fed from the suction line, just like the rest of our pumps, and it's also discharged to this line, taking the water all the way to the fire hose reel. Alright, so let's perfect this connection. What I mean by perfect this connection is, let's bring in the isolation verb, the check verb or non-return verb, and also the strainer. Yes, the strainer is another important component in this connection. The Y strainer. We are going to be making use of a Y strainer on this suction line to protect the impeller and seals of this pump. This strainer serves as a filter to filter in deads or solid particles coming out from this tank to feed this suction line. Let me show you what I mean. So this is a strainer. Water comes from this inlet, this direction, and comes out through this outlet. But before it does come out through this outlet, it goes into this section of the strainer. This is a strainer. Inside this section, this pocket, there is a filter, a mesh screen that traps solids in order not to feed the pump with the solids. So this is a typical example of how it works. Once the water comes in, you can see the water first enters into the mesh. These black particles you are seeing, the deads, the solids, and then a clean water goes out through the outlet to gain access to the pump. So this is the mesh screen. You can see it, the filter, right? This is it. For our jockey pump, this is a jockey pump. You can see it's a vertically it's a vertical component. So remember I told you its function is just to boost. Alright, so let's use this drawing to create our isolation verb or a get verb and our non-return verb. So this will represent our non-return verb or check verb. This will represent our shut off verb or isolation verb, also known as get verb in this case. Let's reduce the scale. explain their functions and the order at which they are to be placed. Let's include a gate valve on this discharge line as well, and our suction line. Now let's bring in something to represent our strainer. So because we are viewing it from the top, we will not be seeing the pocket where the mesh is located. But I believe you get the idea. And don't worry, when we bring in our tank elevation, we will do it. We will place it. Okay, so now let me explain. This is a gate valve. It is positioned before the strainer on the suction line. You don't place a strainer on the discharge line, you only place it on the suction line. Why? Because that is where the water makes its first entry into the pump. So to protect the impellers and seals, you position the strainer before the pump, but after the gate valve. Why you are placing it after the isolation valve or gate valve? In case of any maintenance, if you want to carry any maintenance on the strainer or you want to replace the strainer, all you need to do is to shut off this valve in order not to drain the whole water in this tank, not to drain the whole system, just because you want to carry out maintenance on this strainer. So that is why it's positioned after the gate valve. The same goes for the non-return valve or check valve and the gate valve here. When you want to carry out any maintenance on this check valve, you just shut off this valve in order not to drain the system, this wet pipe. Remember, I told you that this wet pipe is supposed to be charged with water at all times. So in order not to drain this wet pipe, that is why we are placing the gate valve after the check valve. So when you are carrying out any maintenance on this check valve, you just shut off this valve and carry out your maintenance accordingly. So the purpose of this check valve now is, you know, when there is minor losses on this discharge pipe, the jockey pump activates. Now it will be forcing water to this line up to this point. So that force now will make water to go into these pumps to create water hammer and reverse flow, which might damage the pumps. So now even though there is a gate valve, but at times the gate valve can be mistakenly left open, or it might be faulty. So now this non-return valve will not allow this water, the water coming out from the jockey pump, to find its way back into the pump, either of the pump, whether the electric or the diesel. That is why they all have non-return valve. So likewise, if the electric pump is working and these two are ideal, water will of course tend to come back into the pumps. So this non-return valve will not allow the water to find its way into the pumps. It only allows flow in one direction, and that is this direction, that is the left side. The water can only pump, the pump can only discharge water to come through this line, but cannot the water cannot find its way back into the pump due to the non-return valve. So that is that about the check valve and the gate valve. Now let's bring in our tank elevation for detailing. Why are you hooking? All right. Okay, let's copy this to our drawing. So now this elevation will make us understand more especially the strainer part. Okay, this is our fire pump, this is our lift pump. No, in this case this water lift pump, that is the pump that takes water from the ground tank to our overhead tank, will not be visible. Why? Because you can see the position of the lift pump, it's at this side of the tank, while the fire pump is on this side. So when you are viewing it from here, when you are viewing the fire pump and tank from this side, the lift pump will not be visible. So we are going to take it out of the picture now. Alright, so let's draw something to represent our strainer. Let's copy this. Instead of drawing the strainer all over, we can just use this component and convert it into a strainer, a Y strainer. That is what we are going to be using. To 25 degrees. Okay. think this can represent our strainer. Yes. So let's give it a red color. Yes, so now this is the way to position the strainer if the water is coming from this side, so that it will first make its way to this pocket, then the filter filters the debts, traps the debts, and a clean water moves out to the pump. And it is always, the pocket should always face down, so that the debts will be acted upon by gravity. Now the next thing is our isolation valve, which is a gate valve in this case. I believe you know about valves. It's not all the time that a gate valve serves as an isolation valve. We have many other valves like butterfly valves, the needle valves, and so on. Depends on the purpose you want the valve to serve. So this is our check valve. Let's convert them to red all. So I believe this connection is okay. Now let's bring in something to represent the elevation of our jockey pump. due to time factor, we're going to call it a day. We will continue in the next session. Thank you for watching. See you in the next session.